The iron in your blood came from a dying star. The calcium in your bones filtered through ancient limestone before it ever reached your glass of water. The carbon in your skin was once part of a plant, which pulled it from the air, which got it from the ocean, which got it from another living thing that died a long time ago. Every atom in your body was borrowed. 7 octillion of them. That is a 7 followed by 27 zeros, and not a single one belongs to you. You assembled them over a lifetime, held them together with chemistry and stubbornness, and now the universe wants every last one back. The question is how long you make it wait. And the answer depends almost entirely on what someone does with your body after you are gone. Not what prayers are said, not what is written on the headstone, what physically, chemically, thermodynamically happens to your remains. The difference between the fastest method and the slowest is not days or weeks, it is centuries, in some cases, half a millennium. A body sealed in a casket inside a concrete vault can delay the return for 500 years. A body composted with wood chips and alfalfa completes the handoff in 30 days. And there is a calculation I want to show you later. A very specific, very unsettling calculation involving Julius Caesar that makes the whole question of returning atoms feel profoundly different than you probably expect right now. But before we get there, you need to understand what you actually are, chemically. What has to happen, atom by atom, to take you apart? A 70-kilogram human body is, by mass, mostly oxygen, about 43 kilograms of it. Then 16 kilograms of carbon, 7 kilograms of hydrogen, almost 2 kilograms of nitrogen, a kilogram of calcium concentrated almost entirely in your skeleton, about 780 grams of phosphorus. Then smaller amounts of potassium, sulfur, sodium, chlorine, magnesium, and trace elements that together weigh less than a bag of sugar. By atom count, the picture shifts. You are roughly 60% hydrogen, 26% oxygen, 11% carbon, and the rest is everything else. You are, in other words, mostly water and air with some charcoal scaffolding and a calcium frame. Nothing exotic, nothing rare. Everything in your body exists in enormous quantities in the soil, the ocean, and the atmosphere. The universe is not missing these atoms, but it will reclaim them. The second law of thermodynamics guarantees this. The only variable is the timeline. Now, the standard Western burial is, from a physics standpoint, a remarkable act of defiance against that reclamation. Think about what it involves. First, you take a body and inject it with embalming fluid, typically formaldehyde-based. Formaldehyde is a powerful fixative. It cross-links proteins and kills bacteria, essentially turning soft tissue into something closer to leather than living flesh. Then you seal that preserved body inside a casket, hardwood or metal, lined, cushioned, latched shut. Then you lower that casket into a concrete vault sunk into the earth. And what you have done, whether you intended to or not, is build a series of nested barriers between your atoms and the rest of the biosphere. The formaldehyde slows microbial decomposition from months to years or even decades. The sealed casket cuts off oxygen and blocks insect access. No blowflies, no beetles, no larvae. The concrete vault prevents groundwater from infiltrating and carrying dissolved molecules away. Under these conditions, soft tissue decomposition takes 10 to 50 years, depending on soil moisture and temperature and how effective the seal remains. Skeletal remains. The calcium phosphate matrix that gives bone its rigidity can persist for 50 to 100 years or more. A complete return of all your atoms to active biological circulation, that can take 300, 400, 500 years in dry, stable soil. Think about what that means. 5 centuries of your calcium sitting in a concrete box underground, cycling nowhere. 5 centuries of your carbon locked in embalmed tissue while outside, above, the biosphere is churning. Plants pulling carbon from the air, animals eating those plants, organisms dying and feeding new organisms in an endless loop that your atoms are locked out of. The universe has been running this cycle for 13.8 billion years without interruption, and you have asked it to pause for 500 more. Now here is what happens if you skip all of that. If you let your body do what it has been quietly preparing to do your entire life. A natural burial. No embalming, no casket, no vault, just a body wrapped in cloth and placed directly in soil, follows a very different timeline. And it follows it because you have removed the barriers and let biology do what biology has been doing for hundreds of millions of years before humans decided to intervene. Within hours, the bacteria already living inside you begin the work. You carry roughly 38 trillion bacterial cells in your body while you are alive. In your gut, on your skin, in your mouth. They outnumber your own human cells. And the moment your immune system stops functioning, they shift from symbiosis to consumption. The anaerobic bacteria in your intestines, the same organisms that helped you digest dinner last night, begin breaking down your tissues from the inside. They produce methane, hydrogen sulfide, carbon dioxide. This is the bloat stage. It is not pleasant to think about, but it is extraordinarily efficient chemistry. Your body is a closed system being opened from within. Within weeks, once the expanding gases have broken the skin and oxygen reaches deeper tissue, aerobic bacteria take over. Fly larvae arrive. Blowflies can detect a body within minutes of death in warm weather. In forensic science, the progression of insect species colonizing a body is so predictable that entomologists use it as a biological clock, and what they have documented is remarkable in its efficiency. Active decay, the phase where aerobic bacteria and insect larvae consume remaining soft tissue, proceeds over weeks to months. The body becomes a temporary ecosystem, a concentrated burst of nutrients feeding hundreds of species of bacteria, insects, and fungi. In temperate climates, skeletonization occurs within 6 months to 2 years. Your carbon returns to the atmosphere and soil within 1 to 5 years. Your nitrogen enters the soil. Nitrogen cycle within months, taken up by plant roots, converted by nitrifying bacteria, cycling exactly as the second law predicts. A naturally buried body returns most of its atoms to active circulation within a single decade. So already you can see the scale of the difference. Traditional burial, centuries. Natural burial, years. But neither of these is the fastest method. Modern cremation occurs at temperatures between 760 and 1150 degrees Celsius. To put that in perspective, iron melts at 1538 degrees. Wood ignites at around 300. Your body, at these temperatures, does not slowly decompose. It combusts. Carbon bonds with oxygen to form CO2 and exits through the exhaust stack. Not over months, not over weeks, within minutes. The carbon atoms that yesterday were part of your brain, part of the proteins that encoded your memories and your personality, are atmospheric carbon dioxide by lunchtime. Hydrogen leaves as water vapor. The same hydrogen that was water in your cells that morning becomes water vapor in the atmosphere that afternoon, free to condense into a cloud, fall as rain, be absorbed by a plant, become part of a fruit eaten by a stranger in another country. Nitrogen exits as N2 and nitrogen oxides, rejoining the atmospheric nitrogen pool that makes up 78% of every breath anyone takes. The combustion is thorough. So thorough that what remains, the powder people call ashes, contains virtually no carbon, no hydrogen, no nitrogen at all. What is left is almost entirely calcium phosphate from your bones, along with trace minerals. The calcium and phosphorus that spent decades forming the rigid lattice of your skeleton, ground by a machine called a cremulator into the fine gray powder that gets placed in an urn. Everything that made you organic, everything that made you alive in a chemical sense, is already gone, already cycling. Cremation returns roughly 95% of your atoms to active circulation within 2 to 3 hours. Your carbon enters the atmosphere the same afternoon. Your hydrogen joins the water cycle before the sun sets. The 5% that remains, the calcium and phosphorus sitting in the urn on someone's mantle, persists indefinitely in mineral form unless someone scatters it. If they scatter it into soil, those minerals become available to plant roots within months to years. 2 to 3 hours versus 500 years. That is the range. And remember that calculation about Caesar one mentioned? We are almost there. But first you need to understand the two newer methods, because they change the math in ways that matter. Alkaline hydrolysis, sometimes called water cremation or aquamation, places the body in a pressurized stainless steel vessel with a potassium hydroxide solution heated to roughly 150 degrees Celsius. Over 3 to 4 hours, the alkaline solution breaks down proteins, fats, and DNA into a sterile liquid containing amino acids, sugars, salts, and soap. Yes, soap. The saponification of body fat, the same chemical reaction that has been used to make soap for thousands of years, is one of the primary processes occurring inside that vessel. Your body fat literally becomes soap. Bones remain intact and are processed into powder, just as in cremation. But the difference that matters is this. In fire cremation, your carbon exits as atmospheric CO2, a greenhouse gas that contributes to warming. In alkaline hydrolysis, your carbon exits as dissolved organic molecules in liquid form. That liquid, sterile, nutrient-rich, faintly coffee-colored, can be discharged into municipal wastewater treatment systems or used directly as fertilizer. Your atoms return to the biosphere not through the atmosphere but through the water cycle. Same speed, different path. Roughly 1/7 the energy consumption of traditional cremation. No combustion byproducts, no mercury vapor released from dental fillings, no particulates, no dioxins. Then there is human composting, and this is the one that surprised me. Washington State legalized it in 2019, with several states following since. A company called Recompose developed the commercial process, founded by a woman named Katrina Spade, who had been thinking about this problem for years. The body is placed in a vessel, essentially a large insulated container shaped like a hexagonal cradle, with wood chips, alfalfa, and straw. Thermophilic bacteria, heat-loving microbes that thrive at elevated temperatures, colonize the mixture and raise it to between 55 and 70 degrees Celsius. That is hot enough to pasteurize, hot enough to break down pathogens, and hot enough to decompose all organic material, including bone. Over 30 days, everything is converted. Not most of it. Everything. The result is approximately 1 cubic yard of nutrient-rich soil, enough to fill a pickup truck bed. All of your carbon, nitrogen, phosphorus, calcium, and trace elements transformed into biologically active soil in 1 month. That soil can grow plants immediately. Your atoms enter living organisms directly. No atmospheric phase, no mineral residue sitting in an urn on a shelf for decades. Every atom back in the game within 30 days. From a pure physics standpoint, human composting achieves the fastest and most complete return of all your atoms to the living biosphere. Cremation is faster for the 95% that combusts, but it leaves that 5% behind as mineral powder. Composting gets everything. Every last atom reintegrated into living soil within a single month. If this were just a question of speed, a simple ranking of methods from slowest to fastest, we could stop here. Traditional burial with vault, up to 500 years. Natural burial, a decade. Cremation, 2 to 3 hours for 95% of you, but your bones sit in an urn indefinitely. Alkaline hydrolysis, the same speed, through water instead of air, at a fraction of the energy. Human composting, 30 days. Everything, no remainder, no exceptions. But this is not just a question of speed. There is something deeper going on. And there was one man who understood all of it. The cycling, the statistics, the absolute mathematical certainty that your atoms will scatter more deeply than anyone who has ever lived. The universe took him apart too. In the 19th century, there was a physicist in Vienna named Ludwig Boltzmann, a large man, bearded, intense, prone to bouts of enthusiasm that could fill a lecture hall. He was one of the founders of statistical mechanics, the branch of physics that explains how the collective behavior of trillions of atoms gives rise to the macroscopic properties we observe: temperature, pressure, the direction of time itself. Where other physicists saw smooth, continuous matter, Boltzmann saw atoms. Incomprehensibly many of them, jostling and colliding and redistributing energy according to the laws of probability. And Boltzmann understood something that most of his contemporaries refused to accept. He understood that the second law of thermodynamics, entropy always increases, disorder always grows, is not a divine commandment carved into the fabric of the universe. It is a statistical certainty so overwhelming that the distinction between probability and law essentially vanishes. It is not that entropy must increase. It is that the probability of it not increasing is so vanishingly, absurdly, incomprehensibly small that the number of years you would have to wait to see it spontaneously reverse has more digits than there are atoms in the observable universe. So it is not going to happen. Boltzmann spent decades defending this view, and he defended it largely alone. Many of his colleagues did not even believe atoms were real. This sounds absurd now, but in the late 1800s, the existence of atoms was genuinely controversial. Ernst Mach, one of the most influential physicists and philosophers of science of his era, openly ridiculed atomism. He considered atoms a useful fiction, nothing more. Boltzmann argued passionately that atoms were real, that their statistical behavior explained thermodynamics, that the macroscopic world emerges from microscopic chaos. He was right about all of it. But being right did not protect him from the professional isolation and personal anguish that came with decades of opposition. In September 1906, while on holiday with his family in Duino near Trieste, Boltzmann took his own life. He was 62 years old. His wife and daughter were nearby. The reasons were layered and heartbreaking. Chronic health problems, severe depression that had worsened over years, the accumulated exhaustion of decades fighting for ideas that his own peers treated with contempt. He had recently accepted a prestigious chair at the University of Vienna, hoping it would bring some measure of peace. It did not. Here is the part that makes it sting. Just a few years before Boltzmann's death, a 26-year-old patent clerk in Bern named Albert Einstein published a paper on Brownian motion, the random jiggling of tiny particles suspended in water. Einstein showed that this motion was exactly what you would predict if the water were made of atoms constantly colliding with the particles. It was the first truly persuasive evidence that atoms exist as physical objects, not just theoretical conveniences. Within a decade, the scientific world accepted what Boltzmann had been arguing for 30 years. His atomistic worldview became the foundation of modern physics. He did not live to see any of it. His gravestone stands in the Zentralfriedhof in Vienna, in a section reserved for the city's most honored dead. Carved into the stone above his name is his most famous equation. S equals K log W. Entropy equals Boltzmann's constant times the logarithm of the number of microstates. It is perhaps the most profound sentence ever written on a tombstone. 5 symbols. Because that equation describes, in those 5 symbols, exactly how the universe disassembles everything, including you, including me, including Boltzmann himself, into its most probable arrangement. The most elegant summary of mortality ever written, inscribed above the body of a man who understood it better than anyone. Which brings me to the calculation I promised you. It is sometimes called the Caesar's last breath problem, though the physics applies to anyone who has ever lived and died and exhaled. The math goes like this. Julius Caesar exhaled roughly 22 liters of air in his final breath, approximately 10 to the 22nd power individual gas molecules. That is a lot of molecules, but the atmosphere is enormous. It holds roughly 10 to the 44th power molecules total. So the odds that any single molecule you inhale was part of Caesar's dying breath? Absurdly small. About 1 in 10 to the 22nd. But you inhale 10 to the 22nd power molecules with every single breath you take, and when you multiply an absurdly small chance by an absurdly large number of tries, you get approximately one molecule, from Caesar's dying breath, in every breath you take, right now. Think about that for a second, and not just Caesar. The math works for anyone who lived long enough ago for their exhaled molecules to mix thoroughly into the atmosphere. Cleopatra. Boltzmann. The nameless farmer who tilled a field outside Rome 2,000 years ago. Your great-great-grandmother. Every human being who ever breathed and died and returned their atoms to the air. Their atoms are in you right now. Not metaphorically, not poetically, not poetically. Physically, statistically, demonstrably, The calculation is straightforward and the result is unambiguous. It goes further than breath. The water you drank this morning contains hydrogen and oxygen atoms that have cycled through billions of organisms over the past 4 billion years. The carbon in your muscles was CO2 in the atmosphere last year, was part of a corn plant 6 months ago, was part of the soil before that, was part of another organism before that, stretching back in an unbroken chain to the first photosynthetic bacteria that learned to pull carbon from the air. Every atom in your body has a history that dwarfs your own. Your entire life is one brief chapter in each atom's autobiography. You see, this changes the question entirely, because the question was never really about how fast your atoms return to the universe. Your atoms are not yours. They never were. They were Boltzmann's before they were yours. They were part of a fern in the Carboniferous period before that. They were forged inside a star before that, in nuclear fusion reactions that took millions of years, and then scattered across space in a supernova explosion that outshone an entire galaxy for a few weeks. You are a temporary arrangement of atoms that have been cycling for billions of years and will continue cycling for billions more. What you call your body is just the current configuration, one arrangement in an inconceivably long sequence of arrangements. But you are not separate from that sequence. You are not a thing that borrows atoms and then returns them, like a library book. You are the cycling itself, briefly aware of itself. A pattern in the current, not the water. This means the choice between burial methods is not really about you at all. It is about what comes next. Every year your carbon remains locked in a sealed casket underground. Is a year it is unavailable to become part of a blade of grass, a rainstorm, a child taking its first breath. Every decade your calcium sits in embalmed bone. Inside a concrete vault is a decade it cannot become part of a coral reef or a bird's egg or the limestone that will filter someone's drinking water 1,000 years from now. You are holding borrowed materials. The question is only how promptly you return them. The methods that work with the second law rather than against it, natural burial, cremation, alkaline hydrolysis, composting, are not just faster. They are, in a very real sense, more generous. They return what was borrowed. Completely. Without demanding centuries of artificial delay. Boltzmann understood this at the deepest mathematical level anyone has ever reached. S equals K log W. The universe is a system of constant exchange. Concentrated order disperses. Always. Not because the universe is hostile to order. It clearly is not, or you would not be here reading this, but because there are so overwhelmingly many more ways to be disordered than ordered, that the math leaves no room for alternative outcomes over time. Your body is a spectacularly improbable configuration of atoms, trillions of them organized into cells, organs, a nervous system capable of contemplating its own disassembly. The second law does not destroy that configuration out of malice or indifference. It simply describes the statistical landscape. There are very few ways to be you. There are unfathomably many ways to be everything else. And given enough time, everything else is what your atoms will become. A sealed casket fights this with barriers. A natural burial cooperates with it. Cremation accelerates it. Composting transforms it into something that can sustain new life immediately. And none of these methods are wrong, exactly. They are simply different answers to a question that the universe will eventually resolve on its own, regardless of what you choose. The second law is not a suggestion. It is a description of how reality works at the deepest level anyone has ever been able to reach. But some answers cooperate with that reality more gracefully than others. You know, I have been thinking about what it means to replace 98% of your atoms every year while you are still alive. Think about that. It means the you sitting here now is not physically the same collection of atoms that existed a year ago. Almost none of the same atoms. And yet you are still you. Your identity, your memories, your sense of self, none of that requires keeping the same atoms. It requires the pattern, the arrangement, the information encoded in how those atoms are organized. And when you die, the pattern stops being maintained. But the atoms, every single one of those 7 octillion, go on to form new patterns. In soil, in water, in the bodies of other living things. Not your pattern, but patterns nonetheless. The universe does not waste material. It never has. S equals K log W. 5 symbols carved into a gravestone in Vienna that describe how the universe takes everything apart and reassembles it into something new. The man buried beneath that stone spent his entire career trying to convince the world that atoms were real, that their statistical behavior explains why time moves forward, why heat flows from hot to cold, why a cup that shatters on the kitchen floor will never spontaneously reassemble itself. He fought for this understanding until it broke him. And then, a few years too late, the world proved him right. But his atoms did not stay in that grave. They cycled out, as Boltzmann himself would have predicted, into the soil of Vienna, into the roots of the linden trees above his grave, into the rain over the Danube, into the air you just inhaled. His atoms are everywhere now, as yours will be. The only question the second law leaves unanswered is how long you make the universe wait before you let them go.